Hey everybody, welcome back. So I have this Sencore model TC-154 tube checker, and I kind of want to start using it because these are kind of unique tube testers when you compare them to some of the other emissions tester. It is still an emissions tester, but it does have a really good grid leakage circuit for testing grid leakage and so forth. Very, very sensitive. It can read up to 100 mega ohms. So they're kind of desirable, and there were many different versions of this tube tester. The earliest ones used vacuum tubes in the circuitry in them. The later models, such as this one, use a FET, so it's solid state, so as soon as you turn it on, it works. But I want to be able to check the calibration on it. And all of these units, they give you an instruction in here, and I've printed it out from the service manual, how to make your own calibration jig. And you only need a few components to do this, so I'm going to make one. You can see they're just showing an 8-pin octal socket, and then you need a diode, just a silicon diode, a 100 meg resistor, which those are kind of hard to come by. They want you to use 4 22 meg and 1 12 meg all in series, but I actually have a 90 meg and a 10 meg that I can put in series, and we'll test those here before we install them. They want a 270K resistor and then a precision 1K 1% resistor. So I went into my parts and I was able to dig out all of the components I need. And this is an octal socket, and it's not off of an old tube, but it's actually an old relay, an octal plug, I should say. I'll see if I have one. I could show you what these looked like when they were still intact. So it's something like this. You can see that's what this came off of. And these make really good base sockets, for an octal tube socket. So you can take them apart. This one had mounting holes in it, and this one does not, so it's a little bit different. This one, the cover goes on from the sides, but it's the same idea. So basically what you can do is you can cut all this stuff off and clean out the pins and use it for a base. And that's what we're going to do. So out of the components that you need, if you look down here, let's zoom in a little bit. You can see that we need a 100 mega ohm resistor. The rest of this stuff's pretty easy to find. But 100 meg resistor, you can order them. I know DigiKey and Mauser and them sell some. A lot of them are for high voltage, so they're real big. But I looked through the couple of high resistance resistors I had in stock, and I actually found a 90 mega ohm and a 10 meg, and they're both precision. And so measuring high resistances like this, not every single meter can go that high. I don't know if the Fluke will measure it, but I thought maybe it'd be fun on this video just to try that real quick. So let's zoom back out. And got the Fluke 187. Let's see if it'll go up to 90 meg. I know the 10 meg it should be able to read no problem. So here's the 10 meg. And sure enough, 10 mega ohms. Let's see what it does with the 90 meg. It reads it. Look at that. 89.5 mega ohms. Now, if you have to read really high resistances and your meter won't go that high, they do make a device specifically designed for high resistance, and it's called a megavolt, and sometimes they call them a megger. The old megalodon. But essentially what these do is they work by applying a high voltage to the device. It's heavily current limited, and it allows you to measure really high resistances. As a matter of fact, you can see there is a mega ohm range, and the lowest number it starts at is 1 mega ohm, and it goes clear up to 500 meg, 1 gig ohm, 2 giga ohm. So it gets up pretty high. That being said, this silly little Keithley 197 over here that I use sometimes, and let me get the thing out of the way, it actually has a 2 giga ohm range on it. So it pretty ridiculously high resistances it can read. And of course these all use this and the Fluke and all that. They use a low voltage to measure those resistances, whereas this one uses a 1000 volt. I think it's 1000 volts, or maybe this one's 600 volts. Regardless, it's high voltage. And that does help when you're trying to measure for something that has that'll break down with shorts and so forth. This might read something, whereas one of these low voltage testers will not. So they're handy for that. But just for fun, we'll use it to just get a demo of how this thing works. And you turn it on mega ohm mode. And we'll touch it here. And you don't want to put your fingers on the probes while it's running, because you can't, even though it's current limited, you get a pretty good zap. And maybe you'll hear the small whistle of the inverter making the high voltage, but here we go. And you can see right there would be 100 mega ohms, and the notch before it would be 90. That's just about right on there. So pretty cool. But there's some of these will actually go up to even 5 or even 10,000 volts test voltage, and we use these at work for testing high tension cables for X-ray machines, because of course they're rated up to about 80 kilovolts that they can withstand before the insulation will break down. But sometimes the core of the cable will break down and arc internally, and you'll get these little carbon tracks. And even though these meters here will read very high resistances, as you just saw, there's no voltage, there's no real high voltage here, and it won't break it down sometimes. But this, when you use it, it will. And it'll cause it to kind of arc over, and you can actually see the resistance in there. You can see that there is a partial short. And that will eventually, when you get really high voltages on it, it'll break down really hard and act almost like a dead short. It'll even burn the wire eventually, and that happens. But it sometimes can be difficult to troubleshoot that without something like this. So that's what they're used for, at least for us. Okay, as you can see, this is our schematic, our 3 resistors and our diode. And to attach these to the base, essentially what we want to do is we want to count out the pins. Now, if you look at the bottom of the plug like this, just like it would with a vacuum tube, the key, which is this little bump here on the center post, that key indicates where pin 1 is going to start. So pin 1 is always to the left, so it's clockwise around this way you count. So here's the key. The first one after the key would be pin 1, 2, 3, 4, 5, 6, 7, and 8. So that's how we're going to connect them. And if you look, they want pin 3 to have the anode of the diode. They want pin 4 to be the 100 meg resistor. Pin 5 we connect to the 270K, and pin 6 we connect to the 1K, and then the other end of all of those components connect in common. So what I'm going to do to make this a little bit more user-friendly is I'm going to put some of these standoff posts on here. I'm going to put the components down in there, and then we'll tie them together through this circuit board, and we'll cut it down to size. So I'm going to trace it out, and we'll just cut it down to size. And then that'll just make it a little neater. It'll be almost like a module that we can plug in to test our tube tester. It's a tube tester. Okay, nothing fancy here. We're just going to score it across a set of these lines. And then we're going to flip it over here and just snap it. And then this side we're going to do the same thing. I mean, you could cut it with a Dremel and a cutting wheel, but then it makes a bunch of dust. I don't like that dust. It gets all over everything. You breathe it. Wear a mask or something, just kind of gross. So, I'll get a pair of pliers. And that's it. Now we can go ahead and mark the holes, and we'll drill it and put the standoffs on it. Okay, drill some pilot holes here, and then you can put the screws in. Hopefully it won't break it. See how close I got it. Oh, that's not bad. Okay. Okay, let's put the standoffs on here. If I really wanted to get fancy, you could put some Loctite, but who cares? This is just a quick little project. Or thread locker, whatever you like to call it. No matter what you call something, somebody will tell you that's not right. You need to call it something else. It's just the way of the YouTube. All right. There we go. And of course, before we put this top on, let's get these components put in here, and then we'll bring them up through. Okay, we've placed these in this way. And then I'm just going to go ahead and kind of roughly pick some holes here where these go, so that they can all be fixed together. I mean, it's not going to be perfect, but who cares? Again, this is just a little thing we're knocking together real quick. Just like so. And then we'll put the tops on here. Put the screws in and drop them on the floor. We can always do that. And we'll straighten them out before we solder them down. Does it really need to be like this? No. Just a goofy idea I have. I thought I'd try. All right, let's find the missing screw, and then I'll be right back. Okay, after a brief spelunking journey, I ran into Mr. Tumnus, who bid me good day and pointed out where the screw was. And now we're back on course here. All right. So I'm going to just pull these up a little bit. And we're just going to crisscross over them. And we're just going to solder them all together. And there it is. Okay. Probably should get something to hold this while I do this. Okay, that's better. Hey, I'm going to make a total mess of this. What the heck? All right. The bigger the blob, the better the job. Is that what they say when it comes to soldering? I'll just tack these down. What fun. All the neatniks are cringing right now. All right. Good enough. No time here. Get this thing done. All right. Now I got to flip it over and do the pins. All right. See if I can make a complete mess of this. I'm going to have to clean it up. Should have heated it up differently than that. Oh well, live and learn, huh? Okay. And then I'm going to clean up the outside of this. I probably should have done this differently. Let's watch Tony make a total hack job out of all this. Right? Nice. That looks good. Okay. This one here didn't fill in. There we go. The rest of them look, yep, they're good. Let's clip them. Whoops. Let's drop that on the floor too. Sorry, Mr. Tumnus. I must have hit him in the head. All right. That's it. There it is. There's our little module. Now we can try it and see if it works. All right, let's check calibration on this. So the first thing we want to do is plug our new module into socket 1 according to the instructions. And we want to turn this thing, let's plug it in here. Turn it on to short. Okay, and we want to set this, and I've already checked it, 1D 6D. All right. And I'm going to turn it on shorts. Oh, and it would help to turn the power on. And we have to set the meter until it's right on 0, and it appears to be pretty close. There it is. Okay. Then it says, using the test module, plug it in as, oh, depress the grid leakage and adjust R11, where am I at? R11, the grid leakage cal control on the meter until it reads on the line between question mark and bad. And you can see it's supposed to read between, right on that line between question mark and bad. It's a little bit off. So we're going to have to adjust that. And then the emissions calibration, we want to hit the emission button, and it should read, we want to move this to C, and it says the meter should read 60. And it's pretty close, but it's off by a little bit. See that? So we're going to have to take this out of the case and make the adjustments. All right, I got it apart, and great. Look at what they put all over it. Why do people do that? It's gross. All right, so let me get that off of there. Okay, after picking the boogers off of the potentiometers, now we can move them. And Let's see, I need to find a tweaker. All right, so let's turn this back on, and we want to adjust this one down here for the grid leakage, and the top one is for the emissions. So let me get on this. We're going to have to go here. Okay, I'm going to turn it on grid leakage. Well, let's make sure that it's zeroed out first. It's not. Now it is. Go to grid leakage. You know what? You're not seeing a daggone thing, are you? Okay. So let's get back on the potentiometer here. And perfect. All right. Then we're going to go back to shorts, make sure that's still set. Yeah, it was off by a little bit. Let's try it again. All right. Nice. Okay. Back to shorts. Looks good. Now let's go to emission and move this to C. And it says make the meter read 60. So it's a little bit high. So we're going to turn it down. Oh, that pot's dirty. That's one of the problems. Okay. We may have to clean that one a little bit. So let's clean that potentiometer, and then we'll be right back. Okay, a little spritzer of cleaner. And let's see if this works better now. I bet it does. Let's see here. Looks good. Nice. I know you're at an angle, but looking straight on, it's perfect. Okay, let's put it back together. Okay. So here's an old 6BQ5 out of a Hammond organ amplifier. And if we go in our book and we look up 6, there we go, 6BQ5. So we want to set this to 6 C1 B. Okay, 6C1B socket 3. Should be this one here. And we'll turn it on to shorts. It says permissible short F and H. And one other pin. Okay. So we will go from B, and we'll rotate through the shorts here and make sure we don't have any shorts. And okay. And this is the light that will light up. So really nothing. Just getting a little flash, but they're not coming on solid for shorts and heater cathode shorts. Okay, so let's take this back to B where it was, and we'll go to grid leakage, and that looks good. There is no grid leakage. We are perfectly good there. And now let's go to emission, and the tube is good. And it's as simple as that. So I do like these. These are really convenient little tube testers. Of course, you're not going to test, you know, transconductance or anything like that, but you can see for a quick, just to check for leakage, shorts, and emissions, great little tube tester. So this will stay here on the bench because it's small size, and I'll keep it nearby. It'll be really easy to do a quick tube test if we need to. We don't have to break out the big tube testers. And that's it. So hope you enjoyed this short video on how to build one of these calibration modules for yourself. Again, these precision this precision 0.1% 1K is easy to find, and of course just a normal 270K, and then just a silicon diode, but like a 1N4007 or anything like that. But you really need to make sure you get this 100 mega ohm, and I just happen to have a 90 and a 10, and they say just to use 4 22 mega ohm, and those are pretty readily available, and a 12 meg all in series. So that's it, and until next time, I wish you all peace, joy, happiness, and good health in your lives, and we'll see you again for the next video. Stay well, everybody, and take care. Bye-bye.